The following math workshop activity was taken from the February 2014 issue of Teaching Children Mathematics.
All of my friends want some carrot sticks. How many friends do I have? 1, 2, 3, 4. I have 4 friends. Let's count and see how many carrots I have. Check. How many carrots does Miss Whitler have?
1, 2, 3, 4, 5, 6. Then you get like...
Oh. My kindergarten friend. I have 4 friends, and I want to share 6 carrots. Here's what I want you to think about for a minute. Go ahead, put your hands down. Think about it and don't shut up. How could Miss Whitler share 6 carrot sticks with 4 friends so that it's fair? I want to share them fairly. How could we share 6 carrot sticks with 4 friends? Guess what? I do have a carrot for everyone, but first, I want to solve this math problem. So you may go sit down. I do have a carrot for everyone, but first I want to solve this math problem. Kindergarten friends, we're going to do problem solving today. And you and your math partner are going to get a bag with 6 pretend carrot sticks. I want you to think about this question. 4 friends want to share 6 carrot sticks. How can they do this fairly? I want you to draw a picture, and you're going to need to be able to explain your answer. You're going to work with your partner. I have carrot sticks for you to take a look at and think about it. And when you think you have some ideas, I want you to draw a picture and explain your answer. You know who your math partners are. If you will please go to your table, Miss Whitler will bring you some carrot sticks and a piece of paper.
After passing out materials, students are given a chance to problem solve with their partner. Students are allowed to get any math materials they would like to use throughout the room. They are expected to stay in their chair, work together, and discuss their solutions and record their thinking. As they are working, I am walking around with a clipboard taking anecdotal notes and also asking some probing questions to help move their thinking along. I'm looking for good strategies as well as common misconceptions or students that I may need to come back to later.
6 of them? Okay. Here's what I'm wondering. Would it be possible for each person to have a whole carrot and then another little piece? Or do they all have to be pieces? Oh, okay.
We have 4 carrots on tip for 4 people. We cut all of them in half. Then they all have 2. Then we cut these in half, and then one that they have for this, and one of the half for this, and then cut this in half. And they get one, and they get this half and this half. Then they all have 3.
After most students have had a chance to solve the problem, we transition to the carpet area for math talk time. I pre-select who will share during math talk time based on the variety of strategies that I saw as I was walking around the room. I typically begin with a less efficient strategy and move toward more efficient strategies as students share.
4 friends want to share 6 carrot sticks. How can they do this fairly? And what did you 2 decide?
That we could get more kids.
Okay.
Like, get some more kids to eat them.
Get more kids to eat them. And then how many kids would you need so that it was fair?
6.
You would need 6 kids. If we didn't want to get more kids, if we just wanted to share our carrots with the kids we already had, Cannon, tell me about your your strategy?
We could cut them and we could get two and put two, and then we could split them and each get one.
Okay, slow down a little bit. All right, so first you have your carrots. Let's make sure they're all there because good mathematicians always
double check.
All right, we have 1, 2, 3, 4, 5, 6 carrots. All right, then what did you do with all of your carrots?
Cut it down.
Okay. How many pieces did you cut them into? 2. Okay, so he cut all the carrots into 2 pieces. Then how many carrots does each person get?
3.
Okay, explain that to me.
Because one gets
Honey, sit down and listen. What are you doing?
one half and one whole one. Then he gets the other one. Then he gets the other one. Then that one.
Okay, do they each get 3 whole carrots or do they each get 3 pieces?
Pieces.
3 pieces. Okay, interesting.
Everybody gets one whole one, and everybody gets one, 2.
So when Cannon showed us his work, he had divided all of the carrots. You girls are saying each person can get one whole one, and then what will you do with your other 2 carrots?
And about, I can't remember, it's about one, I think they both get basically 2 more little slices.
Okay, so they get 1 whole carrot and then 2 more little slices. So Gunnar and Andrew were working, and they said, all right, we have 4 carrots, but then there's 2 left over. So Gunnar, then what did you decide when you had these 2 left over? Tell me that part again.
Break.
To break them. So I told him, go ahead and draw a line to show me where you broke it. So that's why he drew a line. So then, Andrew, tell me again, how many carrots will each child get doing it your strategy?
The 4 kids will get 1/2, whole thing.
Okay, 4 kids get 1 whole thing and 1/2. All right, but if you don't mind, I'm going to draw on your carrots so that your friends can understand what you're talking about. Would that be all right?
Yeah.
Okay, so kindergarten friends, help me count. We have 4 friends, right?
Yeah. Oh, wow.
1, 2, 3, 4. Okay, so each person gets 1 carrot. 1, 2, 3, 4. And then Gunnar is saying we could cut them in half. Each person will get 1 whole one and 1 half. 1, 2.
We conclude Math Workshop with a wrap-up. I like to use Puzzled Penguin a lot of times for my wrap-up. He's a character from the Math Expressions series, and Puzzled Penguin is always doing something incorrectly.
William, what do you think? Did Puzzle Penguin cut his carrot in half?
No,
Why do you say no?
because it's only, not half of it, it's like this one piece.
Well, if he cut it into 2 pieces, see, he cut it right here. There's a piece and there's a piece.
There's not, it's not in the middle.
Why does it need to be in the middle? Quinn, what do you think?
Because it needs to be like the same amount of long, like this and this.
Okay, Brindley?
It needs to be equal.
It needs to be equal. Why?
Because then it's fair.
Then it's fair. Kindergarten friends, you just said a lot of important things. You told me that if something is in half, it needs to be in 2 equal pieces so that it's fair. Would you want this little tiny piece?
No.
Would that be fair?
No.
That is not half, even though it's 2 pieces. To be in half, it has to be fair. It has to be 2 equal pieces.
This lesson was an interesting experiment into kindergartners' understanding of fractions. Thanks so much for joining us for Math Workshop.